All right, we're going to look at the logic practice, and I'm going to try and go in the order that we learned the material. So we're going to start with questions 1 through 4. So the beginning here, just Boolean logic, remember that's putting together more than one statement. And so we're looking at a positive multiple of 5 and not a multiple of 2. And we're trying to see what integers do that. So the multiples of 5 would be like 5, 10, 15, 20, 25, but it can't be a multiple of 2, which would mean it's even. So that's really leaving us with 5 and then jumping up to 15 and then 25, 35, and so on, continuing that pattern. For number 2, we want to be greater than 12 and less than or equal to 18. So we kind of have 3 statements there. So greater than 12 would be 12, 13, 14, but at the same time, and we have to be less than 18, or we could equal it, so we can also include 18. So 15, 16, 17, and then we'll include that 18. So that satisfies those 3 statements included there. For questions 3 and 4, we want to negate these quantified statements. So everyone, that's a universal quantifier. So we're going to say that at least one person passed. For number 4, we're saying someone, that's an existential quantifier. And so if someone in the car needs to use the restroom, then the negation, that would be no one needs to. All right, for our next part, we're going to look at everything that uses the conjunction, disjunction, or negation. So for part 5, that's going to be questions A and B. So it wants to translate each statement from symbolic notation into English sentences. So A is Elvis is alive. So we're going to say here, this is or here. So we're going to say Elvis is alive. Or the G is Elvis gained weight. So we're going to say or gained weight. Or he gained weight, however you want to write that. For number 2, we're saying the negation at the beginning of this whole and statement. So sometimes the way to say that is using words like it's not the case that, and then what follows would all be together. So I'm going to write it like that. It is not the case that Elvis is alive and gained weight. All right, and we'll come back for those other ones. So again, looking for the conjunction or disjunction. So number 6, we want to create a truth table for that. So we know we have A and B as statements. We'll need to have a negation of B, and then we'll be able to combine those together. Since we only have 2 statements, that would be 4 total rows. And we'll put our first column, true, true, false, false, true, false, true, false. And so to negate B, just the opposite of that, so alternating, false, true, false, true. Now we want to put together our A and our negation B, and this is a conjunction, so we need both to be true. So that's going to be false, that will be true, false, and false. So the only time we get true is if A ended up being true and B was false, then our new statement we came up with would be true. For question number 7, set that up. Again, there are only 2 statements there, A and B. We're going to need the negation of A. They'll also need the negation of A with or B, and then we can negate that whole thing. Again, it's going to be just 4 rows to it. And we'll fill that in. We'll do true, true, false, false, true, false, true, false. So to negate A, we'll go false, false, true, true. We need to put A or not A or B together. So as long as one of them is true, we will be true because it's or. So we have everything true here except for that second row. Now we need to negate that last column, so it'll be false, true, false, false, false. Continuing our work here, for question number 10, it just kind of talks about the difference between inclusive or and exclusive or. So often when we say like, I like chocolate or peanut butter, it means I like the chocolate or I like the peanut butter, but really in math we're saying that it could mean that you also like chocolate and peanut butter. And so that's kind of the difference between the inclusive and exclusive or. So just kind of keeping that in mind, like in real life, if you're ordering an entree at a restaurant, so some dish, and it could include a soup or salad, you're probably not getting both of those. So we would say that it is an exclusive or. So that's A or B, but not both. You should bring an umbrella or a raincoat with you. That could include both things, so we'll say that's inclusive. We can keep driving on the I-5 or get on the I-405 at the next exit. You're not going to go on two freeways at once, so it is exclusive. And for the last one, you should save the document on your computer or a flash drive. Really, it could be both. It doesn't really have to be one or the other, so it could be including. All right, we're going to skip over. We're not going to worry about question 11 or 13. You could try them, but it does use a notation that we haven't really talked too much about. So we're going to go on to question 12, which is this truth table. It only has conjunction, disjunction, and negation, which is what we're looking at right now. So it has it started for us, our truth tables. So A or B, this would be true, 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 false. A and B, that would mean both of them have to be true. So that would only happen with that first one. Everything else would be false. So next we want to look at the negation of A and B. So the column we just wrote, negated, would be false, true, true, true. And lastly, it wants us to combine really the A or B, which is this column, along with the negation of A and B. So it wants to put these together, and it is a conjunction, so they would both have to be true. So we have true with false, that's false. We have true, true, so that would be true. True, true again, that's true. And then false, true would be false. So that would be our ending. All right, I'm going to go back now because part 3 we started talking about conditionals. So I'm going to go back to question 5, and parts C and D have the conditional in them. So for part C, if we want to translate that, we know that if Elvis gained weight, then Elvis is not alive. And for part D, this one has the arrow, notice it has it in both directions, so that is a biconditional. So what we're saying is that Elvis is alive if and only if he did not gain weight. Next, we're going to scoot down to create some truth tables. 8 and 9, we have A, B, and C. So I'm going to have to kind of zoom out here and have some space. You should be doing this on separate paper. So we have A and B implying C. So that's our goal for question number 8. And so I'm going to need to have A, B, and C, which is going to mean I have 8 rows going on here. I'll need to find A and B, and then I'll be able to find that truth value there. So we need 8 rows. Maybe that's big enough here. So 2, 4, 6, 8. Okay, and so we're gonna do that kind of consistent pattern, true, 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 4 of those, and then 4 falses. The C is alternating, and B is kind of grouped a couple at a time. And that should get all the different combinations there. So A and B, that means both need to be true. That will happen for the first and second rows only. The rest are all false. And so when we look now at this, A and B implying C, remember that the conditional is only true, or is actually true all the time, unless you have true implying false. So we have true to true, that's true. Here's a true to false, that would be false. False always implies, you can see it for all these last ones, it doesn't matter what happens if it's true or false after that. If the hypothesis is false, we really don't know anything about the conclusion. So we're going to have that all of those are going to be true. So for question number 9, we want number 9 to be A or B, implying the negation of C. So similar setup, A, B, C, A and B. We need the negation of C this time. Then we could put the conditional in there. So this will also have to have 8 rows. I could have kind of just deleted what I had before or erased some of that, but we'll stick with this. So we have, there's 2 rows, now we have 4, and we'll divide each of those. That'll get us 8. And so we start again that same pattern. True, 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 4 of them, and then 4 falses. True, false, true, false, true, false for the third one. And then 2 at a time. That's how I always remember them. Okay, so we want A and B together. Oops, not A and B. We want A or B. Let me erase that. And so that's as long as one of them is true. So we're going to get a true, 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 and then these last 2 are false. Now the negation of C, we're looking at the C column, doing the opposites. Remember, it alternated, so let's alternate it the other way. False, true, false, true, false, true, false, true. And so for the implication, we're looking at A or B implying C. So remember that is only false if true goes to F. So true to F, that first one's false. True to true, that's true. True to false is false. True, true is true. True, false is false. True, true is true. And then false implies anything. So those are last ones will be true. All right, going back over here. So we finished all those truth tables. We're going to skip on over to question 14. And so in question 14, we want to consider the statement, if you're under age 17, then you cannot attend this movie. And we have the converse, which remember, if we have P implies Q, the converse just flips that around. So Q implies P. So it would be if you cannot attend this movie, we would probably say then you are under 17. For B, we want the inverse. The inverse just negates both of them in the original. So we would say if you aren't under 17, then you can attend the movie. And you can kind of see with that wording that that's the same thing as the converse. So the inverse and the converse are logically equivalent. Last, the contrapositive, that would be the negation of Q implies the negation of P. This is going to say that if you can attend this movie, then you are not under 17. And that would be equivalent to the original statement. So if you remember that the contrapositive and the original statement, those are always equivalent to each other. And the converse and inverse are equivalent to each other. Okay, for part 15, assume the statement, if you swear, then you will get your mouth washed out with soap is true. which of the following statements must also be true? So I'd like to kind of denote these. I mean, you could read through them and see in English kind of what makes sense, but I like to picture. These are conditionals. So P is if you swear, Q is you get your mouth washed out with soap. And so if we say if you don't swear, we're really saying that that's a negation of P with negation of Q. If you don't get your mouth washed out with soap, so negation Q to negation P. And if you get your mouth washed out with soap, that would be Q, then you swore, implies P. So A and C aren't necessarily true, but B is the contrapositive of that statement, and so then that one would be true. All right, now we're looking at negation. Remember the negation for a conditional, if you have P implies Q, the negation would be P and not Q. So really it's like that premise happens and you still don't follow through, so that's why those would have opposite truth values. So for 16, what we would say is that you don't look both ways and you don't get hit. By a car. For 17, if Luke faces Vader, then Obi-Wan cannot interfere. We would say that Luke faces Vader and Obi-Wan can interfere. For the last one, if you weren't talking, so we'd say you weren't talking and you missed the instructions. For number 19, when you look at the biconditional, you will play in the game if and only if you attend all practices this week. So that means if you play in the game, then you attended all practices. And if you attend all the practices, then you play in the game. So the only one that situation that could occur is that you didn't attend all the practices and so you didn't play in the game. So you could have attended all the practices this week and didn't play. That can't happen. You didn't attend all practices and you played, again, that couldn't happen. It was an if and only if. All right, moving on. De Morgan's laws. We could have done that. That was actually back from part 2. But what it wants us to do is rewrite them using De Morgan's laws. So if you look at number 20, it says, it is not true, which is a negation, that Tina likes Sprite or 7-Up. So we see that we have two statements there, the Sprite, liking the Sprite, and liking the 7-Up. So we're going to call P being that Tina likes Sprite, and Q being that she likes 7-Up. And we're going to put, because it's a not the case of, it would be equal to that. So De Morgan's law says it's kind of like distributing, but what happens is that disjunction turns into a conjunction. So we're going to negate that P and Q and combine it with the word and. So what that would look like then is that Tina doesn't like Sprite and she doesn't like 7-Up. For number 21, again, it starts with it's not the case that, and it says you need a dated receipt, so we'll call that P, and your credit card to return the item. So remember De Morgan's laws again, it's going to be negation P or negation Q. So we're going to say that you don't need a dated receipt or you don't need your credit card to return the item. To return the item. It's kind of short there. For 22, go back and look at the truth tables in 6 and 7 and explain why those results are identical. So let's go back to 6 and 7 And if you look at 6 and 7, we have that negation in the front of that parenthesis. And if we think about distributing it and using De Morgan's laws, this would be the same thing as the negation of A and the negation of B. But when you do the negation, it ends up just turning into A. So we have A and negation B, which is exactly statement 6. So both 6 and 7, you can see in looking back that they had the exact same truth table values. And so you can see that they are in fact logically equivalent. And it also is following from De Morgan's law. All right, for 23 through 28, we're just going to kind of skip around to some of these. Looking at question 23, we're trying to decide if these arguments are valid or invalid. And so for 23, it says, if a person is on this reality show, they must be self-absorbed. Laura is not self-absorbed, therefore Laura cannot be on this reality show. So right away, I just kind of picture some if-then statements. So I'm going to write the argument here. We have that person is on a reality show, we call that P, and being self-absorbed, we'll call that Q. So we have that P implies Q. We have that Laura is not self-absorbed, so that would be that we have and not Q. So remember, we're starting to put argument together. We're going to put the statements, combine them with the word and then what we want to do is show that this whole thing will imply that Laura cannot be on this reality show, which would be negate P. So we want to see that it is equal to the negate P. So to set up the truth table for that, again, we need some extra space. I'm going to have, it's just P's and Q's, so that's really nice. So that means that we're only going to have 4 rows to that. We're going to need to know negation Q. We're going to need to know P implies Q. And then we're also going to need to know negation P. We actually need to know, we need to know this whole fact here. So we're going to need to know P implies Q and negation Q. And then the last one, we're going to need that whole statement there. So it will be P implies Q and not Q. And we want that this implies not P. So we're going to check on that. So again, we need 4 rows. So I split it in half and then half again. Okay, and so then we have true, true, false, false. Again, we follow that same pattern, alternating for Q. And so then we're going to look at not Q. That's the negation of all those. False, true, true. We have a conditional here. We want to look at P implying Q. So true to true, that's true. True to false, that's really the only time that a conditional is false. These other times, if your hypothesis is false, then it doesn't imply anything. So we get that those are true. Now we want to combine, we're using and here, the conjunction of the conditional and that negation. So we're going to look at those together. So a conjunction is only true if both things are true. So we're going to get a lot of false going on here. And the last one will be true. And so then when we're looking at this conditional, we're looking at this last column we made, implying a negation of P. And I realize I don't have negation of P. I'm going to write that over to the side here. So negation P would be false, false, true, true. So looking at the false implying false, that is going to be a true statement, because remember, if a conditional starts off false, it doesn't mean anything really. The only thing we're concerned with is if we start with true, we don't want a broken promise. So if we start with true here, it goes to true, so we are all good. So if we get the all trues here, that's a tautology, and so we have that it is in fact valid. All right, let's see. How about we could look at 24. And this time we could look at doing it with Venn diagrams. So we're going to kind of scroll down here. So it says, if you are a triathlete, then you have outstanding endurance. So let's think about all the people that have outstanding endurance. And so inside of that is going to be the people that are triathletes. Now we know that LeBron James is not a triathlete. So that means that he is not going to be inside that red circle, but he could be in that endurance circle, or he could be outside of it. And so when we look at our conclusion, LeBron does not have outstanding endurance. There's nothing that says he's forced to be outside of the circle. He could be inside of it. And so we're going to say that that is an invalid argument. Let's look at 25. So for 25, it says Jamie must scrub the toilets or hose down the garbage cans. Jamie refuses to scrub the toilets, therefore Jamie will hose down the garbage cans. So let's rewrite this. I'm going to use the truth tables. Kind of alternate here. So Jamie must scrub the toilets, we'll call that P. Hosing down the garbage cans, we'll call that Q. Now she refuses to scrub the toilets, so that's going to be a negation of P. And therefore Jamie will hose down the garbage cans, that's Q. So what we have for this one, we're going to ignore the logical fallacies. It's kind of interesting stuff. You can read that if you'd like, but we're going to ignore that for our course for now. We're just doing a little introduction to logic. So we have that P or Q. So Jamie must scrub the toilets or hose down the garbage cans. And negation P. So that's all the situation that's going on. We want to see if this will imply that Jamie will in fact hose down the garbage cans. So it implies Q. So that's our goal there. So let's put down, we need P's and Q's. We need P or Q. We need a negation P. We need this whole entire statement itself. I'm just going to stick it in here. And then we're going to also need the whole entire conditional. We'll put that right here. So instead of rewriting it, I'm just going to draw those arrows. We only need 4 rows again. I have neater lines than I do. And we start our process, true, true, false, false, true, false, true, false. So now P or Q, that disjunction means at least one of those is true. So we'll get true, 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 and then false. The negation of P, that just negates everything in P, the first column. So it'll be false, false, true, true. So now what we're looking at is the and of the P or Q and not P. So we're kind of combining those together. The only time that conjunction is true is if both are. So we're going to get a false, false, true, and then false. So then last, we want to look at the conditional. And our conditional here is looking at this last column we made and seeing if it implies that column Q. So false implying true, remember that's always true. So anytime you start with the false, we're going to end up with true. If you start with true, you want to make sure it's true, which it is. And then again, we have one last false one, which is going to be true. And so we get all T's are tautology, and so we can say that it's a valid argument. Okay, for question number 26, let's take a look at, let's go back and forth, Venn diagram here. It says some kids are rude. Some of these kids are rude. Jimmy is one of these kids. Therefore, Jimmy is rude. So I'm kind of, if you read that, it sounds very valid. Not everything that sounds that way is, but let's take a look at this. It says some of these kids are rude. So if we look at all the rude people, we would have some kids in there. So there would be just an overlap that there are some kids that are rude. Now it says that Jimmy is one of these kids. So that means that Jimmy is living inside that overlap. And therefore we know that if he's in that overlap, then he is in the rude circle. So Jimmy is rude. So that would be valid. For question number 27, I'm going to let's just do this. We can make this our last one here. It says every student brought a pencil or pen. So we have the pencils, and we have people that bought pens. It doesn't say that they didn't have both, so we're going to put them kind of overlapping for a minute. And it says Marcia brought a pencil, therefore Marcy brought a pencil, therefore Marcy did not bring a pen. So there's nothing to say that Marcy doesn't live in that overlapping section. Like there could be an overlap. So because we don't know that, we can't say that she did not bring a pen because she could live inside of that. So that would be an invalid argument. Okay, I guess we do one more, 28. Let's do Venn diagrams one more time. Let's see if we can fit this in. If a creature is a chimpanzee, then it is a primate. So let's put the primates. And if a creature is a chimpanzee, then it is a primate. So we're going to put chimpanzees inside here. And it says if a creature is a primate, then it is a mammal. So all of those primates have to live inside the mammal circle. So it says that Bobo is a mammal. So Bobo is living somewhere inside that red circle. Well, he could live there or in there or there. So when it says that therefore Bobo is a chimpanzee, well, he could be, but there's nothing to say that he couldn't have lived in just the primate and the mammal area. So that would again be invalid.